All right, here's another proof. It says, given that 1 and 2 are supplementary, so they're telling us that angle 1, this green one, and angle 2, this yellow one, are supplementary. Remember, that means that they add up to 180. And then they're saying that 3 and 2, angles 2 and 3, the orange and the yellow one, also add up to 180. So they want us to prove that angle 1 is congruent to angle 3. So if 1 and 2 add up to 180 and 2 and 3 add up to 180, then 1 and 3 must be the same measurement. So that, again, for some of you that might be obvious, like, well, of course they must be the same. But we need to go through the steps. See, look, I have 6 steps in this proof to prove step by step, statement by statement, that this is actually true. So you want to use the definitions, the theorems, the properties, and the postulates in the geometry manual. So you always start off with whatever they told us was given. So I just wrote there, angle 1 and angle 2 are supplementary, angle 2 and 3 are supplementary. The reason I can make this statement is because it was given to us. So I've already kind of told you, well, if angle 1 and 2 are supplementary, then that means that they add up to 180. Measurement of angle 1 and measurement of angle 2 must add up to 180 because the definition of supplementary angles says if you have 2 angles that are supplementary, then that means that they add up to 180. So we're able to go from the fact that we know they're supplementary to these 2 equations because of the definition of supplementary angles. That's why we can make that statement. Now, let's keep going. Okay, so here what I did is I substituted. I said, well, if these add up to 180 and these add up to 180, then you can substitute those 2 equations into each other. So think of it like this. If this is 180, then in the second equation, instead of 180, I'm going to write that. I substituted one equation into the other. Where there was 180, I wrote the measurement of angle 1 and plus the measurement of angle 2 instead. So I have this. Now, there's something called the reflexive property. If you have something and it equals something else, you can always say that that's true, or you have something and it equals itself, you can always make that statement to be true because of the reflexive property. I always think of it as a reflection, reflexive. So I can make this statement that the measurement of angle 2 equals the measurement of angle 2. So I'm going to use what we said in statement 3 and in statement 4 to come up with a new statement. If I know that measurement of angle 2 equals measurement of angle 2, then I can subtract the measurement of angle 2 from both sides of the equation in statement 3. If I subtract the measurement of angle 2 here, and I subtract the measurement of angle 2 here, then that cancels out. And I'm just left with the measurement of angle 1 equals the measurement of angle 3. You could subtract the same number from both sides of an equation because of the subtraction property of equality. And since we know measurement of angle 2 and measurement of angle 2 are the same number, then we could subtract that from both sides. Sorry. So the last step, we know the measurement of angle 1 equals the measurement of angle 2. That's not what they want us to prove. They want us to prove that angle 1 is congruent to angle 2. So in order to get to that last statement, we can change it to that because that's actually the definition of congruent angles. So I changed it from this to this because That's the definition of congruent angles.